Hey there, class. Mr. Pusky here. Hope you're having a good day so far. We're continuing with chapter 5. We covered slope-intercept form. We covered point-slope form, if that was taught this year. I believe it usually is. But we're covering a new form of a linear equation, which is a standard form of a linear equation. So, standard form is quite simply, it is this. It is ax plus by equals c. So slope-intercept form is y equals mx plus b. Point slope is y minus y1 equals m times x minus x1. This is point slope. And then standard form is when we have x and y on the same side of the equation and then the constant all by itself. Okay? It says note a, b, and c are real numbers. Also, a and b cannot both be 0. And x and y are on the same side of the equal sign. And actually, one thing to be careful about is that a, b, and c should all be integers. And integers are going to be what's called positive and negative whole numbers. They do not include fractions or decimals. They do not include fractions or decimals. Okay? So A, B, and C are all, it actually should be integers we're going to put right here. Okay? For it to be in standard form. You can still have fractions and decimals, it just won't be in standard form if they're not integers, basically. Positive or negative whole numbers, okay? All right, we have an example. Just write the equation in standard form with the given, with integer coefficients. Typically, the x term is written as a positive value. That's sometimes, it's not always. We're going to get practice with it, but just be aware that sometimes teachers or other textbooks want you to have the x term, the a value to be a positive. But not always, okay? So, we have y equals 5x plus 9. We need to get x and y on the same side, and the x value needs to be positive. So if I need to move x and y on the same side, well, I have y over here, and I have x and the 9 over here. I'm probably going to subtract 5x from both sides. I think would be a good idea. You could also subtract 9 and then subtract y. You can move this over here and this over here. That's a little bit extra work, though. By doing this, we're going to have negative 5x plus y equals 9. Remember, we cannot combine y and 5x because those are not like terms, okay? And it says, like it says, the x term is usually a positive value. To make that change, we need to multiply by what number changes signs? It's going to be negative 1. We're going to multiply the entire thing by negative 1 to change the signs. So then we get 5x changes the signs. Positive y becomes minus y. Positive 9 becomes negative 9. And now we have, this is the standard form, we have x and y on the same side, and the a value is positive. All right. Cool. All right, let's do it again. We have number 2. We have 2x plus 17 equals 3y. We need to get x and y on the same side, and we need to, get x and y on the same side. So let's go ahead and do that. You know what I'm probably going to do here? I'm probably going to subtract 17 from both sides first. I'm going to do that because that's going to make the life a lot easier. You'll see why in a second. You can move the 2x, you can move the 17 or the 3y, but you want to try to get x and y on the same side as easily as possible. By doing this, you can see we have 2x equals 3y minus 17, and then we can subtract 3y from both sides to get x and y on the same side. And we have 2x minus 3y equals negative 17. The way that I did it on my notes is what I did first was I subtracted 2x from both sides. Let's do it another way over here to show you can do it a couple different ways. I subtracted 2x from both sides, and then I have 17 equals negative 2x plus 3y. I'm going to flip these around so that the negative 2x plus 3y is on the left-hand side. That's a commutative property. That's totally fine to do. And then I multiply both sides by negative 1. To get 2x minus 3y equals negative 17. Okay, so either way is totally fine. I think the first way is probably a little bit easier, but as long as you get x and y on the same side and you get the constant all by itself on the other side, and all the numbers are integers, positive or negative whole numbers, and the a value is positive, then we're good to go. But some people right here, this could actually be an answer right here. The negative 2x plus 3y equals 17. Not all texts or curriculums make the first number have to be a positive, but we're just doing it just to get the practice to make sure we're good to know how to do it. Okay? All right. Moving along here. It says on the next page, sometimes you will need to clear the equation of a fraction. It says clear the fraction and write in standard form. So the first one we have here is 3x plus 9 equals 7 halves y. So this is called fraction busting. And what you do for fraction busting is you're going to multiply basically both sides by the least common denominator basically between all of these. So the least common denominator between both sides is going to be 2. We can multiply both sides by 2 to get rid of the fraction in the denominator. So we got to distribute this 2 to both of these. So 2 times 3x is 6x. 2 times 9 is 18. And then the 2's are going to cancel over here. That's why we do this, to get it. Now we have just 7y. We have a nice whole number to work with. Okay? Now I want to get x and y on the same sides. I think what I'm going to do first, I'm going to keep everything positive. I'm going to subtract 18 from both sides and keep the 6x where it is. 7y minus 18. And then I'm going to subtract 7y from both sides to get 6x minus 7y equals negative 18. And there's our answer. All right, number 2, we have y equals 2/3 x plus 4/3. What's the least common denominator we're going to multiply by to cancel everything? We're going to multiply both sides by 3. So we're going to get 3 times y is 3y. And then we're going to get the 3's are all going to cancel. We distribute the 3 to both of these. We're distributing. We're going to get 2x plus 4, right? If you multiply and divide by 3, they cancel out. That's why we did that in the first place. Okay? All right, now I want to get x and y alone on the same side. What I'm going to do this time, I'm going to subtract 2x from both sides to get x and y on the same side. And then I'm going to have negative 2x plus 3y equals 4. And now what's wrong with this problem right now? Well, the a value, the x value, is not positive, so we're going to multiply both sides by negative 1. And we're going to get, it's going to change the sign, so 2x minus 3y equals negative 4. All right. Sounds good. All right, next thing's a little bit tricky, but we've been talking about Hoy-Vux for a while, so hopefully it's not too bad. All right? So it says horizontal line or slope of 0. It's going to be y equals the y coordinate of the point. And if we're looking for a vertical line or undefined slope, it's going to be x equals the x coordinate of the point. So if you want a horizontal line through 7, negative 3, it's going to be y equals negative 3, which is the y coordinate, right? And in this case, we want the undefined or vertical equation through it. It's going to be x equals 7. Okay? So that's kind of a shortcut. Basically, if you have a point, it says horizontal line through this point, or slope of 0 through this point, or a vertical line through this point, or an undefined slope through this point, you're literally just going to take x equals the x coordinate or y equals the y coordinate. Okay? So, yeah. So for this problem, the x coordinate is 7, so it's going to be x equals 7 is the vertical line, and we have y equals negative 3 is going to be the horizontal line or 0 slope. All right? And then parallel lines. What lines are parallel? If it's going to be x equals number, it's also going to be, parallel lines are also going to be both vertical lines, right? If they're going to be parallel, they both have to be vertical, so it's both going to be x equals and x equals. And if they're horizontal, they're going to be y equals and y equals a number. All right? Perpendicular lines, though, this is a vertical line, so we need a horizontal line, so that's going to be x equals and y equals a number. And then y equals and x equals a number. All right, that's just kind of, so basically all lines that have the form x equals a number, those are all parallel lines because they're all vertical lines. And all lines that are horizontal are going to be y equals and y equals. But then if they're perpendicular, they're going to be opposites. They're going to be x and y and x. All right, it says write an equation for a horizontal line that goes through x equals, 2, 1. So here's our x and our y. Well, horizontal line in Hoy-Bucks is y equals the y coordinate. Well, what's the y coordinate? Is it 2 or 1? It is 1. So we get y equals 1 as our answer. That's all we got to do. All right. And then it says write an equation for a vertical line that goes through 2, 1. Well, that's going to be x equals 2. It's x equals the x coordinate. Let's draw some lines here now. Let's draw a line like this. Not perfect, but it'll do. You see how that's a horizontal line? That's y equals 1. That's literally this line right here. Let's draw a line to this line. And then we have x equals 2 is going to be a vertical line. X equals 2 is a vertical line through x equals 2, basically. Okay? So if we want a horizontal line through 2, 1, it's going to be y equals the y coordinate. And if we want a vertical line that goes through 2, 1, it's going to be x equals the x coordinate. That's literally what we need to do. Okay? All right, now let's fill in the Hoy-Bucks thing again here. See if you can fill it out on your own. See if you remember everything. Well, H stands for horizontal. 0 equals the slope. Y equals the number of what the equation looks like, and it's going to cross the y-axis. It's a vertical line. It's an undefined slope. X equals the numbers, what the equation looks like, and it crosses the x-axis. Okay? So, now it says write an equation for a line with a slope of 0 that goes through negative 8, 13. Well, slope of 0 is a horizontal line. Remember Hoy-Bucks here. It's a horizontal line, so it's going to be y equals, and the y coordinate is 13, so it's going to be y equals 13. Write an equation for a line with an undefined slope that goes through 0, negative 7. Well, that's going to be a vertical line through x equals the x coordinate. It's going to be x equals 0. All right, sounds good. All right, moving on. We got, looks like 2 left here. It says write an equation in standard form of the line that passes through the point with a given slope. Okay. Well, you know what? It says to use point slope form. Did I use the point slope form up here? I don't think I did. So I'm going to do it in point slope form in case I'll do it with point slope form, and I'll also do it with, I'm going to do a standard form as well, okay? Or with slope intercept form here, okay? So yeah, so point slope form is y minus y1 equals m times x minus x1. Okay? So basically we're going to plug in, this is our x1, y1. We're going to do this problem 2 ways. So just be aware we're going to do it 2 ways. And we're going to do it the way it says on the sheet here. We're going to do it the other way too. Okay? So we have y minus y1. Well, the y value is negative 6. So minus negative 6 is plus 6 equals, and let me explain what we're doing here. Sorry. We are writing an equation in standard form, but we're only given a point and the slope. And so what we have to do is we have to use the point and slope form because that's what we have. And then we have to solve for b, and we have to get write an equation in standard form by getting everything like in slope intercept form, and then moving stuff around to get it by itself here. You'll see what I mean when we get closer here, okay? So let's fill in the blanks here. We got m is negative 4, and then we have x minus negative 1 is plus 1. Okay, so that is point slope form. That's a type of a way to write the equation with a point and slope. Now we're going to go ahead and distribute. So we're going to have y plus 6. We want to get the y, not y by itself right now, but negative 4 times x is negative 4x, and negative 4 times 1 is negative 4. So now we want to get, for standard form, we want x and y on the same side. So what we need to do is combine like terms first, and we're going to move the x and y to the same side. So what I'm going to do next is I'm going to subtract 6 from both sides to get y by itself. Negative 4x minus 10. And then I'm going to add 4x to both sides to get x and y on the same side. Okay? So we get 4x plus y equals negative 10. And that's in standard form, okay? So we took something in point slope form, and we move stuff around, we distributed, and then we move stuff around, and we got x and y on the same side to write it in standard form. That's kind of all we did. Let's go back, let's do this a different way. Let's go back and using point slope, or slope-intercept form, that is. So y equals negative 4x plus b. Let's do it the other way too. So we have y, our x and y, our y is negative 6 equals negative 4, our x is negative 1 plus b. Then we're going to do negative 4 times negative 1 is 4 plus b. Subtract 4. We get negative 10 equals b. So we're going to have y equals negative 4x minus 10 like we had here. See, it's the same thing. You can do it either way. You can use point slope form, or you can just use the regular way we were doing it by getting it in slope intercept form and then moving stuff around. And then we can add 4x to both sides to get x and y on the same side to get standard form. And then we're going to get 4x plus y equals negative 10. And that's our final answer. Okay? So either way is totally legit. I think point slope form is a little bit trickier compared to what we were doing, but if it's more useful for you, it's also good to have fluency with all the different types of linear equations too, linear forms. All right, last example. Is this last example? I think it is. All right, write an equation in standard form of the line that passes through the 2 points. Okay, so we need to get either have it in probably in slope intercept form. We need y equals mx plus b, and then we can move stuff around and get x and y on the same side. So the first thing we need to find for slope intercepts, we need to find the slope. So we're going to do the slope. Remember, we do x1 y1, x2 y2. We're going to plug into the slope formula, which is y2 minus y1, which is going to be negative 3 minus 7 over x2 minus x1 is 2 minus 4 equals negative 10 over 2 minus 4 is negative 2, which equals 5. So that's our slope. So we're going to plug into this point slope formula too, using one of the ordered pairs. So that's y minus y1. Let's just write that up here. Y minus y1 equals m times x minus x1. All right. So we're going to do y minus, I'm just going to use 4 and 7 because those are both positives. So I'm going to do y minus 7 equals 5, which is our slope, times x minus 4, which is our x1. Now to get this in slope intercept form, we need to move stuff around. We need to distribute. So we're going to distribute here. We have y minus 7 equals 5x minus 20. All right, we're getting closer. Now I need to move the 7 over by the 20 to get y by itself. To get y equals mx plus b. So y equals 5x minus 13. All right, and now what I need to do is I need to get x and y on the same side to get it in standard form. So we're going to subtract 5x. Negative 5x plus y equals negative 13. And what's wrong with this problem right now? Well, we have x and y, the x value is not positive, so we're going to multiply by negative 1 on both sides and change all the signs. 5x minus y equals positive 13. And that's our answer. Okay, and there's our answer in standard form. If we did it the other way, I'll just show you how to set up the other way. You would do y equals 5x plus b, right? We would just plug it in. We're going to plug in 4 and 7. So we had 7 equals 5 times 4 plus b. So we get 7 equals 20 plus b. Subtract 20. Negative 13 equals b. And then you would get your slope intercept form would be y equals 5x minus 13. Then you would move stuff around like we did over here for this problem. Okay? So either way is totally legit. So in summation, how do we do these kind of problems? First thing you need a slope and you need an intercept. Okay? You need a slope and a y-intercept. And which means we need slope-intercept form. So you can use point slope form. You can solve for b, doing like we did over here with this. And then after you get things in slope-intercept form, which is y equals mx plus b, that's the easiest form to be able to move stuff around and get x and y on the same side to make sure that x is positive, okay? So for this problem and this problem right here, for standard form, you're going to either use point slope or slope-intercept form, and you're going to move stuff around, get y by itself, and then move all the x to the same side as y. and you're going to get a final answer, which is going to be something like this, like 5x minus y equals 13, where these are all integers. These are all positive or negative whole numbers, and it's going to be the a value is going to be positive, which is positive 5 in this case. All right, thank you for watching. Have a great day. We will see you soon.